last time we talked about mathematical operators in Python and making meaningful output. I can just run what we did last time, just so that we can see the result of our equation. So what we did was we started combining strings or words, right, and numbers or mathematical statements, so that our result would actually display our equation, okay, as well as the answer. So one of the things I want to get into today is this idea of variables, okay? And so variables in Python are very similar to variables in mathematics. So I just did a quick little search in Google here and just looked up variables in mathematics and some of the things that you commonly see. This looks like something that you might see in a grade 9 math class where you have one variable here, you have a coefficient, a mathematical operator, and some constant values. Okay, here we have one variable, an addition sign, and a number. Okay, some of the, maybe in a formula, you would have seen a couple different variables, specific things like circumference, an equal sign. Here's a constant, our value pi, and a radius. Okay, so mathematically, the symbols represent, take the place of a potential value. Um, a definition of a variable. Um, Variables in algebra, a symbol, usually a letter, standing in for an unknown numerical value in an equation. So one of the differences between, say, mathematics and in Python or code, that variables sometimes can represent not just number values, but they can also take on the values of strings or words, for example. So today I'm going to introduce a couple different ways to use variables to represent the different types of data that we can have in Python. So right here we have print Mr. Hill. And what is Mr. Hill? Well, Mr. Hill is a name. Okay, so I can create a variable called name. And I know that my name is going to be a word, so I have to wrap it in these single quotes. And I'll put Mr. Hill in brackets here. Okay, and so now I have a variable, and it's called name, and it's following this camel case convention. So usually variables don't begin with a capital letter, always a small case letter. Never a number or a special character. So it's usually a small case, a lowercase letter. And you can combine words, but usually the second word that you would combine, for example, this could be my full name, for example. And what you would do is the first word would have a lowercase, and then every additional word that you attach to it would have a capital letter. Okay, and this convention in Python is called camel case. Okay, so for now I'm just going to keep it simple, and we're going to stick with name. Okay, now right now I have a variable, and instead of actually printing directly this word Mr. Hill, let's print name. Okay, actually we can do both. So I'm going to write a print statement here, and because I already have my quotes included in the value of my variable, I can just write the word name, the variable name, in my brackets. Okay, so essentially printing name and printing Mr. Hill, maybe we'll say Mr. D Hill, okay, so that we can see that it's different. But these are two ways of doing the same thing. Okay, so now in my output over here I have Mr. D Hill or Mr. Hill. Okay, now one of the benefits of doing that is that if I am using variables to represent my output, it's easier for me to change. It's easier for me to change my program if I'm using variables. So right now I have a program right here that it prints a name. Now, if I hard code it, right, the value Mr. Hill in there, it would only ever print Mr. Hill. Okay, but what if I wanted to write a program that would print any name, right? It's a lot easier for me to right, to change one value up here, right? So let's say Ms. Duarte. Okay, I can change the one value at the top, and then the rest of my program could stay the same. So that's one benefit of using a variable here. So now we have Ms. Duarte as our output, and our print statement stays the same. Okay, so we can use variables to represent strings or words, and we can also use numbers. Now, if you hop back in here and have our variable section over here, one of the most common ways of representing a variable is by using a letter, and X and Y are both very common. So I can use this in my program. So I can introduce, so if you look at these examples right here, 1 and 2 are common values that get used throughout. So what I can do here, let's create a variable called X, and X can be equal to, we're going to set X equal to 1 for now. And let's create another variable called Y, and we're going to say Y is equal to 2. Okay? Now, throughout my code, I'm going to replace, right? I'm going to replace my my ones and twos with variables. Okay? And we'll see how this makes a difference. So for now, let's just do one statement at a time. So X plus Y is equal to the result of X plus Y. Okay? And we can run this. And so now our output ends up being X plus Y is equal to 3. Okay? Now it might be useful to know what X and Y are equal to. Okay? So for now, for this statement here, I'm going to create another two statements just to say that what are my values of X. So I can say print, right? And remember, I want to show that X equals something, so I need to have that kind of word part of my statement there, X equals, comma, okay, and now I want to have my value X in there, okay, and I'm going to do the same for Y. Control C, Control V, right, copying and pasting your own code in Python is really common, or any coding language, so Y and Y. So now when we read this, and I'll run this, so what we've done here is we created this little word statement part, X equals, and then now we have the actual value that X equals up here. So no matter what the value is for X, I can always change this, and this statement will work for any value. So let's run it. So we have X equals 1 and X equals 2, and X plus Y is equal to 3. Okay, and we know that that's true. Okay, so now we can start to see some of the benefits here. So if I wanted to change my X and Y, I can change this to say 2 and 4, and my equation now will still work. If X equals Y and Y equals 4, X plus Y is still equal to 6. So we start to get more equations that are more generalizable and programs that are more usable when we start to introduce variables. So now let's just say we created a whole bunch of these statements. So let's go ahead and replace all our ones with X, X, and Y. And 1 is equal to X, and 2 is equal to Y. And I can do it down here. Okay, so X and Y, and X and Y here. Okay, and one more, X here and Y here. Okay, now we haven't come up with a number for this yet, but we can still replace 2 with Y and work at these statements here. So X and Y and X, oh no, X, this is Y, 2 is equal to Y. Okay, and so we'll talk about these extra little numbers after, but maybe you can already start to see a pattern here. So we can run this, and let's see the result of our output. Okay, so now I have X is equal to 2, and Y is equal to 4. Now X plus Y is equal to 6, right? 2 plus 4 is equal to 6, and X minus Y is equal to negative 2. So 2 minus 4 is equal to minus 2. now I have 2 times 4 is equal to 8, plus 4 is equal to 12. Okay, and so that's still true. And then 2 divided by 4 is still equal to 0.5. And 5 mod y, remember y is 4, so 5 mod 4 is equal to 1. So 5 divided by 4 is equal to 1, with 1 left over, and that's why we get that answer. Now, to make this complete, I could suggest, what would you do? What could we do with 4? Okay, perhaps create another variable. So, we have x, y, I'm going to throw in z. That's a classic. Maybe just because I like things in alphabetical order, I'm going to put a w up here. Okay, so w and z. Now, it's not a convention, it's just a preference. Okay, and let's say w is equal to 4, and down here we'll have z is equal to 5. Okay, so I've declared all my variables, right? In a mathematical statement, you might say, let w equals 4, and let w equals 2, and let y equals 4, and let z represent 5. Okay, but in this case, we can just define them with one Python statement. Okay, and 4, like we said above, 4 is equal to w, and down here, 4 is equal to w. Right, so we're making our statements more generalizable. Okay, and generalizability is generally better in mathematics because it means that we can use our equations more. Right, if I can write an equation that can be used 100 times, it's better than an equation that can be used only once. Right, one of the things in mathematics, you're always looking for universalizability. Okay, generalizability. Okay, what is true for all statements? Okay, so we can run this, and without getting too deep, right, this is really getting a working knowledge of Python and trying to make the connection to mathematics. Okay, so we have x and y are equal to 2, right? Now, one thing that we didn't do here, and maybe you can practice, but um, let's write a few, maybe a few statements that would add w and z, to this list of output. Okay, can you come up with, your own set of mathematical equations using variables, right? And practice changing the values and creating some output so that you can create meaningful equations with answers, and that you can change the values of your variables so that these equations will work for any of the values you use for your variables. Okay, we'll stop there. I think that's a nice introduction to using whole numbers, which we call integers. Okay, and strings, which is what the programming word for words in Python. So there's a start to two different types of values that we can use in two different types of data that we can use in Python and mathematics so far. Okay, so I hope that helps, and don't be afraid to ask questions. We're going to keep building on this, and hopefully it'll help you start to see the connection between some of the ways that you can solve problems in mathematics and using Python as a tool to help you do this. Okay? Have a great day, guys.